What is meant by conservation of charges? Now, conservation of charges means in an isolated system, the total charge must remain constant. It should be always conserved. We will take an example. Suppose I have two materials which are neutral, and I will transfer electrons from one material to another. So let this be A and this be B. Let this contain 100 electrons and 100 protons. This example is again taken for simplicity. In reality you can't have such an example. And suppose this contains some 300 electrons and 300 protons. And remember, all materials by nature they are neutral. So this is neutral because there are equal number of negative and positive charges here also. Now suppose material A loses 10 electrons to B and they are received by B. So 10 electrons are transferred from A to B because of rubbing or any other method of charging. So when the electrons move from A to B, now this contains, the new numbers will be, material A contains 90 electrons and 100 protons, whereas this material contains 310 electrons and 300 protons. Now if you count the total number, earlier the total number was 100 electrons, 100 protons. Here 300 electrons, 300 protons. So if you put the total number of electrons were 400 electrons and 400 protons. Now if you take the total number now, it will be equal to, so here 90 electrons and here 390 electrons. You make the total, it is 400 electrons. And what about here? 100 protons and 300 protons. Then it comes to 400 protons. So the total number hasn't changed and it remains the same. So total charge is remaining constant. Only the thing is, some of the electrons have transferred from A to B, but in the isolated system, in this system where the exchange of electrons takes place, the total number hasn't changed. So that is the meaning of conservation of charges. Total charge in an isolated system always remains constant.